Hello again to the friends and companions of the Romak Tech channel. Thank you for choosing this channel as astronomy training. Before everything, thanks for subscribing to like and comment. Astronomy. The solar system orbits within the Milky Way, a barred spiral galaxy that is a prominent member of the local group of galaxies. It is a rotating mass of gas, dust, stars, and other objects, held together by mutual gravitational attraction. As the Earth is located within the dusty outer arms, there are large portions of the Milky Way that are obscured from view. In the center of the Milky Way is the core, a bar-shaped bulge with what is believed to be a supermassive black hole at its center. This is surrounded by four primary arms that spiral from the core. This is a region of active star formation that contains a much younger, population I star. The disk is surrounded by a spheroid halo of older, population II stars, as well as relatively dense concentrations of stars known as globular clusters. Between the stars lies the interstellar medium, a region of sparse matter. In the densest regions, molecular clouds of molecular hydrogen and other elements create star-forming regions. These begin as a compact prestellar core or dark nebulae, which concentrate and collapse, in volumes determined by the gene's length, to form compact protostars. As the more massive stars appear, they transform the cloud into an H2 region, ionized atomic hydrogen, of glowing gas and plasma. The stellar wind and supernova explosions from these stars eventually cause the cloud to disperse, often leaving behind one or more young open clusters of stars. These clusters gradually disperse, and the stars join the population of the Milky Way. Kinematic studies of matter in the Milky Way and other galaxies have demonstrated that there is more mass than can be accounted for by visible matter. A dark matter halo appears to dominate the mass, although the nature of this dark matter remains undetermined. Stellar astronomy. The study of stars and stellar evolution is fundamental to our understanding of the universe. The astrophysics of stars has been determined through observation and theoretical understanding, and from computer simulations of the interior. Star formation occurs in dense regions of dust and gas, known as giant molecular clouds. When destabilized, cloud fragments can collapse under the influence of gravity, to form a protostar. A sufficiently dense, and hot, core region will trigger nuclear fusion, thus creating a main sequence star. Almost all elements heavier than hydrogen and helium were created inside the cores of stars. The characteristics of the resulting star depend primarily upon its starting mass. The more massive the star, the greater its luminosity, and the more rapidly it fuses its hydrogen fuel into helium in its core. Over time, this hydrogen fuel is completely converted into helium, and the star begins to evolve. The fusion of helium requires a higher core temperature. A star with a high enough core temperature will push its outer layers outward while increasing its core density. The resulting red giant formed by the expanding outer layers enjoys a brief lifespan, before the helium fuel in the core is in turn consumed. Very massive stars can also undergo a series of evolutionary phases, as they fuse increasingly heavier elements. The final fate of the star depends on its mass, with stars of mass greater than about 8 times the Sun becoming core collapse supernovae, while smaller stars blow off their outer layers and leave behind the inert core in the form of a white dwarf. The ejection of the outer layers forms a planetary nebula. The remnant of a supernova is a dense neutron star, or if the stellar mass was at least 3 times that of the Sun, a black hole. Closely orbiting binary stars can follow more complex evolutionary paths, such as mass transfer onto a white dwarf companion that can potentially cause a supernova. Planetary nebulae and supernovae distribute the metals produced in the star by fusion to the interstellar medium. Without them, all new stars, and their planetary systems, would be formed from hydrogen and helium alloy. Solar astronomy. At a distance of about 8 light minutes, the most frequently studied star is the Sun, a typical main-sequence dwarf star of stellar class G2V, and about 4.6 billion years, GIR, old. The Sun is not considered a variable star, but it does undergo periodic changes in activity known as the sunspot cycle. This is an 11-year oscillation in sunspot number. Sunspots are regions of lower than average temperatures that are associated with intense magnetic activity. The Sun has steadily increased in luminosity by 40% since it first became a main sequence star. The Sun has also undergone periodic changes in luminosity that can have a significant impact on the Earth. The Maunder minimum, for example, is believed to have caused the Little Ice Age phenomenon during the Middle Ages. The visible outer surface of the Sun is called the photosphere. Above this layer is a thin region known as the chromosphere. This is surrounded by a transition region of rapidly increasing temperatures, and finally by the superheated corona. At the center of the Sun is the core region, a volume of sufficient temperature and pressure for nuclear fusion to occur. Above the core is the radiation zone, where the plasma conveys the energy flux by means of radiation. Above that is the convection zone, where the gas material transports energy primarily through physical displacement of the gas known as convection. It is believed that the movement of mass within the convection zone creates the magnetic activity that generates sunspots. A solar wind of plasma particles constantly streams outward from the Sun until, at the outermost limit of the solar system, it reaches the heliopause. As the solar wind passes the Earth, it interacts with the Earth's magnetic field, magnetosphere, and deflects the solar wind, but traps some, creating the Van Allen radiation belts that envelop the Earth. The aurora is created when solar wind particles are guided by the magnetic flux lines into the Earth's polar regions, where the lines then descend into the atmosphere. Planetary science. Planetary science is the study of the assemblage of planets, moons, dwarf planets, comets, asteroids, and other bodies orbiting the Sun, as well as extrasolar planets. The solar system has been relatively well studied, initially through telescopes and then later by spacecraft. This has provided a good overall understanding of the formation and evolution of the Sun's planetary system, although many new discoveries are still being made. The solar system is divided into the inner solar system, subdivided into the inner planets and the asteroid belt, the outer solar system, subdivided into the outer planets and centaurs, comets, the trans-Neptunian region, subdivided into the Kuiper belt, and the scattered disk, and the farthest regions, example boundaries of the heliosphere, and the Oort cloud, which may extend as far as a light year. The inner terrestrial planets consist of Mercury, Venus, Earth, and Mars. The outer giant planets are the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. The planets were formed 4.6 billion years ago in the protoplanetary disk that surrounded the early Sun. Through a process that included gravitational attraction, collision, and accretion, the disk formed clumps of matter that, with time, became protoplanets. The radiation pressure of the solar wind then expelled most of the unaccreted matter, and only those planets with sufficient mass retained their gaseous atmosphere. The planets continued to sweep up, or eject, the remaining matter during a period of intense bombardment, evidenced by the many impact craters on the Moon. During this period, some of the protoplanets may have collided, and one such collision may have formed the Moon. Once a planet reaches sufficient mass, the materials of different densities segregate within, during planetary differentiation. This process can form a stony or metallic core, surrounded by a mantle and an outer crust. The core may include solid and liquid regions, and some planetary cores generate their own magnetic field, which can protect their atmospheres from solar wind stripping. A planet or moon's interior heat is produced from the collisions that created the body, by the decay of radioactive materials, e.g. uranium, thorium, and 26Al, or tidal heating caused by interactions with other bodies. Some planets and moons accumulate enough heat to drive geologic processes such as volcanism and tectonics. Those that accumulate or retain an atmosphere can also undergo surface erosion from wind or water. Smaller bodies, without tidal heating, cool more quickly, and their geological activity ceases with the exception of impact crat. Thank you very much for being with us until the end of the video. Please do not forget to subscribe, comment, and like. So that is another educational video. God is with you.